translating between Braille and music XML sheet music notation.
Yeah. So like Glenn said, so my project title is the real-time bi-directional translation of music XML to Braille. Yeah, and my supervisor is doing it. Yeah, so the objectives of this project is to develop a system to assist in the teaching of music, specifically for the Pioneer School of the Blind in Worcester. And then also the main focus is to support the real-time translation in the classroom, so where teachers can actually translate the sheet music to the Braille for the students to use, and then also the bidirectional part, which is also translate back. Yeah, so there's two parts, like I mentioned briefly. So it's sheet music to the Braille ready format, and then also the reverse, which is the Braille ready format to sheet music. Yeah, so the method, so this is basically the flow, basic flow. So I'll start with the sheet music in digital form. So it'll either be PDF or it can be JPEG or PNG image formats. This is then run through a program called Audiveris, which is it's built on Tesseract OCR, and it's trained for the actual music sheets and then it converts that to XML, which then I'll be using for my project. Yeah, this is all chucked into a Docker container, just so you don't have to worry about any dependencies or anything like that. So I'll start with the XML for my program. I'll then read this in as input using a sax parser, which will I'll be able to read which XML elements I'm working with and what's the data in that XML element, as well as some attributes of that XML element. And then I'll be using also an input translation file, which I use. And basically, this file will tell the program this XML element needs to apply a certain rule, which I'll explain just now. And then it will give this Braille notation as output, reading notation. And then just will run through my program, and then it'll check each XML element. It will run through and check, is there a rule that applies to this? If there is, give the Braille music notation of it. If there isn't, because my thing only handles up until UNISA grade 3 music things. So if there isn't a rule that applies to that specific XML element, it will just go to the next one and then skip it. Yeah. And then if it finds a rule, some of the rules that I defined in my translation file may depend on more than one XML element. So it might have to read an XML element and then wait for another one before it actually gives the Braille of that. So I give this Braille ready format, which looks something like this, which is not really the most user-friendly thing, but essentially I'll show later what the Apex machine, which is the machine that the blind users will use, translates this to. So we'll translate this to actual Braille dots, which you'll see just now. So then the second part, I'll start with the Braille ready format file. So I can either start with the file that I use, which I'll show more or less that's how I tested my program, or the users can actually write their own Braille ready format, provided they give correct syntax and all of that testing. And then I use the same input translation file as before. So the same rules are applied, but now in reverse, essentially. So it will read the Braille music notation in the input translation file. It will have to first convert that to the Braille ready format using hash map, which just maps the two different things to each other. And then it will give the XML element of that. If it reads one symbol, and then the next symbol, it decides that it needs both those symbols to equal one XML element, it would rather use that because that's a more accurate representation of which XML element it should use. And then it runs through, so it will run each element, each thing, and then as soon as it hits the end of the line, I use an XML writer to create my XML file. This basically is just a massive node tree. So the spaces, for instance, indicates like a new music measure. So it will just add a new branch, and then it just builds this big node tree. And then so then I give this new XML file as output to my program, and then I run it through a program called VeroVio, which essentially just reads this XML file and will give me sheet music as output in either, so I just say it gives it in SVG image format, which is just, it's the format that they use. You can also convert it to MIDI audio, which is pretty cool if you just want to listen to what it converts to. So this is quite a popular piece, Flight of Bumblebee. Title's just in German there. So this is just the first page of it. So this is the start input before I even run audio various. It starts with this. This is, I think, this is PNG, just one page PNG file. I then run it through audio various, and this is just the representation of what the Apex machine will translate it to. So I do give it in VRF. I just showed it like this so you can at least see the Braille dots. So for instance, this is just the title. And then, this is just initialization, for instance, the clef and stuff. I'm not going to go into too much detail now. And then it's all of the things. Great, it works. So this is actually, what you listen to is not an original or anything. This is the thing that my program translates this to. So the XML form of this, which my program outputs, actually produces this little 20-second clip, this is only the first page, as output, which is really cool, because if you compare it to the original, what audio various actually received from it, it's pretty similar. You'll notice there will be some changes here, or some things that I don't not account for, but audio various sometimes slips up on some things. And also, for instance, if you look here, for instance, there's beams here, and then there's no here. That is just a syntactical issue that they add to music sheets just for it to be more user-friendly. And for this issue, the Braille, there's actually no Braille music notation for this. So because I'm reading it from the Braille file, there's no way of me knowing how to join these things. So there's no way of knowing that. Then another thing is these squiggly lines, so you'll see they're not there. Audio various actually struggles to read some symbols. So it doesn't actually pick up, it doesn't know what to do with that. It might know that it's a valid symbol, but it might not pick it up in the context. So it doesn't know how to read it, so therefore it's not translated. And then some of the words, it actually doesn't pick up any words in this context. Sometimes it does, sometimes it doesn't. Because it's an OCR, it's not 100%. And because it's been retrained to actually work with the music, it does struggle in some contexts. I think it struggles here mostly because of how much clutter there is around it. And then you'll notice here there's these random extra slurs as well. For some reason, no idea how, audio various picked up that it just needs those there. I looked at the XML, it was also a bit curious. It's just added it to it, I'm not quite sure why. But otherwise, if you look at the other, it might be slightly hard to follow because Veravia, the program that translates it back to the music, actually it uses its own context in terms of how to print it. So for instance, this prints it in 4 bars and kind of squishes it together. The Veravia prints it 3 and then jumps, so this one is actually equivalent to this one, and then it carries on. So, but you can just follow it by the numbers if it gets confusing. Yeah.
That is if you can read music.
Yeah, well, I mean, my thing is not music. You can listen to it. And then why I chose to use the input translation file. First of all, the idea was because I'm only doing it up until UNICE grade 3, it's to be extendable by teachers. It might be hard because it's not the easiest thing to read. You need to first of all know the XML element that the what the music is, the XML element equivalent, as well as what rule to apply, whether it be to print it as soon as you read it, print it now. Well, I've got other rules. It only prints it at the end of each note, stuff like that. So it can be technically extendable if you know what you're doing. And then also to add or change rules. So if they decide that one of the rules, the Braille notation is slightly wrong or needs to be changed, it can be done or the rule, if they don't want it to print at the end of the note or just print immediately, you can just change the rule that applies. And then you can actually use it for testing. So if you only want to see all the whole notes, for instance, you can just remove the rest of the things and see if it actually translates it only with those. Yeah, thanks so much. Any questions? Yes, Josh.
The input that you, on page 5, you said that you can take in a BRF. Can the Apex device that you have specify that, or do you have to actually write the BRF yourself?
So you can write, so on the Apex, for those who are not familiar with it, it's essentially 3 or 6 buttons, and then all these dots is essentially, so you have 1, 2, or 1, 2, 3, 4, 5, 6. So it's literally just a combination of those. So if you, for instance, type 1, 2, 4, 5, if you click those buttons, what will output on the Apex would be the actual symbol. Yeah.
So you can, from the Apex?
Yeah, from the Apex, they can actually create it. I mean, it'll be quite hard to create it without the Apex, but you can. You can also edit it. So, for instance, if you want to change one of these symbols, you can see what it would do if you. Yeah. Yes.
I was looking, sorry, Miss Van, I was looking confused. The music we heard, did your program produce that, or?
Yes. So I'll just go over it. Right. So this is the final output, but this music.
What did you say?
I'll just go, yeah, it's fine. So Mike, after I read in this BRF file,
Yes.
I create this new XML file. So I create this new XML file, which I save here. The Verovio, instead of creating the sheet music like you saw, it can also create the MIDI. So it uses this XML file that I created and it converts it to music. So it should be equivalent to this music sheet. Yeah. Yes, but
Okay, so what I don't quite follow is, well, I doubt whether Flight of the Bumblebee is grade 3 standard. Right?
Okay.
So was that an arbitrary example you chose, or is there some kind of more objective measure that you have of what's the complexity that the system can handle?
yeah, so I was trying to look online for certain grade 3 standard stuff. And because I need it, first of all, there's a couple, I need it in really good quality image, so I can't just like pull it from some like Google image or something. It has to be perfect quality for those who are to read it. So I was trying to use like websites like MuseScore, for instance, to actually pull the music. And most of the stuff from Unisa Grade 3, I never got given access to like the actual music sheets. So some of those music sheets aren't popular enough to actually show on the website. So I did test for some of those, but I just wanted to give a more popular, because I mean I could have given a random piece.
Sure, what I'm trying to establish is, do you have any kind of notion or fix on the complexity of the underlying music that you can handle? For example, you show something that's homophonic, so there's a tune and a little bit of a sort of a chord at the bottom.
Yeah.
But for example, more polyphonic works, so where you actually have 2 separate voices moving. So I mean, is that determined by the actual underlying systems that you use? Is that something you have control over?
Yeah,
Does
so
that make sense to you?
yeah, so like the voices, for instance, that you mentioned, that's actually, I don't think that's part of grade 3. And like all the symbols that aren't in grade 3, my system will just ignore. So like.
Okay. So what's the spec then for what's grade 3? I mean, did they tell you you must be able
So yeah, so I found the piano syllabus of grade 3, and I implemented all those rules and symbols. Yeah.
Right, good.
That answers
Thank
your
you.